All right, I already explained how we get the vertical asymptote is x equals -4. How, can someone explain to Marcelo, he maybe didn't hear me, say it again. How would you like to figure out that the vertical asymptote is x equals -4? Can you convince him of that? Someone. I just explained it in two different ways. Which way do you like? How would you explain that, Anna? If someone didn't know that you were like, the asymptote is x equals -4, and they're like, what? How? How'd you get that? How'd you figure that out? Marcelo, this is for you. Anna, just telling you, and you're not listening. Go ahead. In fact, it'll always be this value right here. In this case, -4, right? Does that make sense, Marcelo?
The opposite of that?
Right. You got it. Is that okay, Marcelo?
Yeah, I just plugged it in wrong, that's why.
I know, you who leans heavily on your calculator is easily led astray. Okay. I read that somewhere. It was like a Zen koan when I was on my self-discovery journey in Tibet. Okay. Good on vertical and horizontal asymptote, because that's critical that you find those. Even though we haven't yet plotted a single point on the curve. Those are like super important in graphing this, okay? The next step is, anyone remember my sweet little recipe? First, find the asymptotes. Next, find 2 points to the left and 2 points to the right of the asymptote. So I would, just because you don't have to, but just because they're convenient, I would pick close values. Values close, in this case, to -4. So give me some values of x that are close to -4. What are some numbers that are close to -4, Nathan? What's an example of a number that's near -4? How about -3? What else you got? 0 is not bad. You can plug 0 in. Can you get closer to -4? Yeah, -2 would be a good one. What else is close to -4? Yes, let's get 2 on the other side too. -5 and maybe, what would you say? A -6. Those are the 4 points I'd probably pick. Though there's no rule. If you want to plug in 0, you're fine doing that, right? There's nothing, right? Plug in 50 if you like. You will get a y value. It just won't be as helpful. This kind of reminds me a little bit. What this reminds me of is, remember when we told you how to graph a parabola back in the day? We said, hey, find the axis of symmetry, find the vertex, and then plot 2 points to the left and 2 points to the right. You remember that? That kind of feels familiar a little bit here. So that's kind of what it makes me think of. All right, and then actually, even without a calculator, we can evaluate these pretty quickly, I think. Plug in -3, what do we get? 3 over 1, will be what that, so that's 3. All right, -2, so what is that? 3 over 2. Or if you want to write 1.5, you could. -5, that'll be 3 over -1, won't it? So that'll be -3. And if you plug -6 in, that'll be 3 over -2, won't it? Or -1.5, if you like. All right, so let's plot those. What do we get? -3, comma 1, 2, 3. -2, comma 1.5. You liking this so far? -5, comma -3. And -6, comma -1.5. All right, we're about to be done. I'm going to draw the graph in a second. So far, so good, though. Stop there and breathe. So how's this going to go? Do you understand why those, it seems like, wait, what does this look like? You really have to understand these graphs to be able to do this, right? You have to kind of have, before you come to this problem, an idea of like what these things look like. You know that these are going to approach the asymptote on both asymptotes. Both curves are going to approach both asymptotes. So here we go. Right? Put arrowheads on both ends, draw it as nicely and smoothly as possible. Your asymptotes are dashed. Your curve itself is solid, a solid line. And your asymptotes are labeled with their equation. It's not just a number, and not just an arrow pointing to the asymptote saying, here it is. Okay? So, you actually want to put the equation down. X equals -4 for the vertical, or y equals 0 for the horizontal. Let's stare at that and appreciate its beauty for a minute. Are there any questions on that? Comments? That's the procedure. I'm going to make you do another one in a minute. So I'm not going to give you any help. I'm just going to make you do it. We could actually also say, maybe let's also say what the domain and range are. It doesn't say that in the question, but let's say what those are. The domain of this is, what do you think? Well, the domain is, what is, remember by asking domain is, what is X allowed to be, is the question. Or, said another way, is there anything that X isn't allowed to be? -4, right? You said it, right? -4. So how do we write that? How can we write that? I think we all have clear in our minds what we want to say. X is allowed to be any real number at all, except not -4, right? How do we write that? I'm fine with you just writing this. Okay? X cannot be equal to -4. Is that an okay agreement? Okay? Everyone will understand what we mean. X is allowed to be anything, but X can't be -4. What about the range? Is there any? What is y allowed to be? Can we achieve every y value? Will there be some coordinate, something,
0,
comma, anything?
Yeah, it's not going to be 0.
Yeah, y will at some time be every number, won't it? Except for 0. Will y ever be 0? Can y be -5?
Yep.
Actually, it can, right? Down here. Y will be -5, 1, 2, 3, 4, 5. Right at this point. I don't know exactly when it is, but we could actually figure it out if you want. There is a time when y will be -5, but there's never a time when y will be 0. So we'll write something similar. Y cannot be 0. That's the range. Y will be every other number. -5,000. Y will be that. Positive 3.75. Y will be that. But y will never be 0. Okay. Is that cool? This is our first time really, even though this is like a warm-up technically, this is really kind of heavy notes. This is our first time really drafting one of these together. Okay. All right. Let me give you this one as practice. I want you to do it. Ready, go. And I want you to, again, think of like we were just doing. Think about this as maybe in terms of transformations of the normal graph. Think about what the H and the K and the A do. And think about my steps. But I don't want to like spell it all out for you. I want to give you a chance to do it. Just like we did in the warm-up. Ready, go. You. You do, good. Yeah. So you're quicker than your calculator. People who are like already jumping into this problem, what are you doing right now? What's the very first thing you're doing? Finding the asymptotes. You gotta have them. Find them, graph them, label them right away. Then we'll talk. do it, you graph those asymptotes. We'll stop there then. Keep going. What do you do next? Just to spoil it for everyone, what is the vertical asymptote? What's the equation of the vertical asymptote? X equals -3. Yeah. Label it, please. And just to spoil it, what's the horizontal asymptote?
-1.
What's the equation of the horizontal asymptote?
Y
Y equals -1. Horizontal lines always have the equation y equals some number. Good. Okay, that's all I'm going to spoil right now. Keep going. So I didn't want to have those wrong as you go forward. At least make sure everyone's on that page. And then what do you do next? What are you doing right now, people who are making progress? Okay, we could say what the domain range is right now, you're right. But how are we going to get the rest of the graph? Yeah, we need some points on this graph, right? How did I pick one? I'll think it through again. I'm going to check your next one. Should be there.
Change them done.
So what are you doing with it? Next, you're plugging in two values to the left and two values to the right. Yeah. Of the vertical asymptote.
Or actually, it's a new one. I gotta go back after this.
You do want to know if this is it? This is the one time? You sure? Let the record hold. 5, 4, 15. Marcelo is going to the bathroom. Is this thing on? Okay. Video. There you go. All right, so you plugged in some points from -3, around -3, right? Would be so. Like, what points do you want to plug in? X values. What is a good X value to plug in? What do you think? I think it's a great choice. What else you got? -1's a good choice, I think. And 0 is not bad too, but we want to pick some points to the left of the asymptote too. So what else? You can do 0 though. I mean, you're also welcome to do that. I'd like to get at least a couple points to the right too, or to the left. Yeah. What's up? Yes.
And then the last year's is behind it.
Oh, look at you. So what other good X values might you plug in? Yeah, -5. What else? Maybe -4, right? It's things close to -3, right? They don't have to be the ones we just picked, but I think those are maybe the best choices. I don't know. So -2. What do we get? What'll that be? -2 divided by 1 is -2 divided by 1 is 1 is -2, excuse me. -1 is -3. Negative 1, what is that? Negative 2 divided by 2 is negative 1, minus 1 is negative 2. Check my arithmetic here. Negative 2 divided by negative 2 is 1, minus 1 is 0. And negative 2 divided by negative 1 is 2, minus 1 is 1. Check me on all those. Okay. All right. So we got 4 points to plot. This is going to be wonderful. Here we go. We'll do these. What's your favorite color? Purple. Okay, perfect. Okay, here we go. Negative 2, comma negative 3. Negative 1, comma negative 2. Negative 5, comma 0. And negative 4, comma 1. All right, I'm feeling this now. Here we go. Questions? Comments about that? Oh, we should say what the domain and range are first. What is the domain? Yeah. You got it. And what is the range, Jonathan? That's amazing. He gets sick with his
No,
yeah. Cool. It does, I saw this one. It's all good. I put Right, y can't be negative 1, right? Good. Any other questions, thoughts about this? I don't have much more to say. Right? You understand my expectations for these graphs? I need you to graph and label the asymptotes. And then 4 other points. Draw the curve really nicely with arrowheads and all that. I guess I do have one more interesting comment about this graph. Maybe it's not what you expected. After the warm-up today, and after our time looking at this graph from Friday of the normal 1 over x graph, this maybe came as a little bit of a surprise to you. What might be surprising about it, do you think? Yeah, doesn't it? You kind of maybe didn't expect these points to land where they do. But then you stop back. You stop and you like step back and you thought, because you're a thoughtful student, maybe it does make sense to me. Why? Why does it actually make sense that this would look this way? That it's, like you said, reflected or flipped. Look at the equation. Because of the what? Because of this negative 1. Maybe not. Yeah, it's because the A value, negative 2, is a negative value, right? Does that make sense? So that's something that you have thought about in your life before. If you throw a negative out front, it flips the function, reflects it over the x-axis for any function that you'll ever meet, ever. For a parabola, that made it so that it flipped upside down, right? Cool. Let's skip this one. All right, one more thing to throw into the mix. You ready? I really want to mess you up now. Okay? Better make sure you get this, because this is new. Write this down. You. All right, there is another form for this equation, okay? And so maybe you're not going to like this, but it is common enough in math that I think you should know it. Okay? I'm going to say right now, it's completely equivalent to the previous form. Maybe I'll even prove that to you at some point. And in this one, we've got an A and a B and a C and a D, okay? And those are all constants. A, B, C, and D are all constants. And you get, when you graph these guys, let A, B, and C, and D be all those, let those be your favorite numbers, okay, whatever your favorite numbers are. And you get the same pictures, I promise. But it's not maybe obvious when you're looking at this what the vertical asymptote is or what the horizontal asymptote is. So let's say what those things are. If you were, and actually here, I'm going to steal, well, let's think about, how about y equals 5x plus 7 over 3x minus 51 or something. I don't know. I'm just making stuff up. Okay. So I want to ask the same question, and I think the most helpful way to think about it is my when does this blow up method that I talked about earlier today, right? So to find the vertical asymptote amounts to asking that same question. When does this blow up? Right? And that's a good question. When does this blow up? Well, it blows up when 3x minus 51 is 0, doesn't it? So when does 3x minus 51 equal 0? You tell me. Don't look at the formulas, just think with me about it. Can you think of a time when 3x minus 51 is 0? What would, that is to say, what would x have to be if 3x minus 51 equals 0? Like I said, you actually don't need to reach for the formulas at all. Just work with it.
17.
Ah, how'd you get that?
51 divided by 3.
Isn't it just the thing that makes this 0 down here? That is, you could actually, and by the thing that makes this thing 0, I mean the solution to this equation, right? Right? That is the vertical asymptote. The thing that makes this function blow up, right? So framed in that way, it's actually the same way of finding it as before. If you're into formulas, then the formula is always going to be x equals negative d over c, right? So in this case, it'll be positive 51 divided by 3, right? So if you like formulas, that's there, but I want to make sure you understand at all times, in all places, why things happen the way they're happening, right? Does it make sense why that's x equals 17? Okay, now this one's even a little bit, if it really worked maybe to explain this one. The horizontal asymptote for this function is given by the equation down here. So if you were just to use this equation blindly, what does it say then that the horizontal asymptote of this function is? It says that it's y equals 5/3, right? Which is completely correct. Let's see if I can give you some intuition for why that's true though. Imagine, because this is really the definition of what we mean by a horizontal asymptote, isn't it? By horizontal asymptote, we mean what is y getting close to? When x gets really, really big. Isn't that what we mean by the horizontal asymptote? So let's try that. Plug in for me into this equation in purple I wrote. Plug into like 1 million for me, if you will. Can you do that? What would you get? Don't do it with your calculator. But if we just do it by hand, what do we get on top? We get like 5 million plus 7, right? But who cares about the plus 7? If we're working with millions, it's basically 5 million on top. And on the bottom, it's basically, if we plug in 1 million, it's basically 3 million. If we're working with millions, the fact that if you just got $3 million and like your cousin asked you for $51, you're like, sure. You know? That's nothing to you. That's pennies to you. So if we plug in 1 million for x, we get basically 5 million over basically 3 million. So what is that? That's basically 5/3, isn't it? So do you understand why, as we get, and if you're not convinced yet, go to 1 billion. Plug in 1 billion for x, and you'll basically get it 5/3, well, 2. So that's the intuition for why this is, what we're saying is out in infinity, the b and the d just don't matter, right? They just don't matter. 7 and the negative 51. The 5 and the 3, man, those things take over the behavior of that graph. All right, so let's try that with this guy. Okay, so here we go. I'd like you to find the vertical and horizontal asymptotes, of course. Do those first, and then do the rest of the process we've been doing, the same way we've been doing it. Label them, get 2 points on the left, 2 points on the right, etc. equation of the vertical asymptote?
X equals 2.
X equals 2. Is everyone clear on that? Is that obvious from the equation? That's right. X equals 2. We're looking for where the denominator is 0. And in this case, you can just look at it maybe and know. The vertical asymptote is X equals 2. What's the horizontal asymptote? Yeah, remember there's a 1 out in front of this X. Whether you see it or not, it is there. So the horizontal asymptote is, what's the equation? Y equals
-1.
1/2,
What?
right?
How do you
Because
get-
again, think about what would happen if you don't like my rules. Think about what would happen if you plugged 1,000,000 in. Wouldn't you get basically 1,000,000 over basically 2,000,000? Wouldn't you? The 1 and -4 are negligible, right? So graph
How do
that.
you find
Yeah.
the horizontal?
It's always the ratio of A to C if you're using the letters I used on the previous slide. Graph nicely, dashed both asymptotes and label them. Remember, we're thinking of this, Marcel, as like y equals a x plus b over cx plus d. Right? And so the horizontal asymptote will always be y equals a over c. Right? So far so good, and then, I mean, really that was it, right? The next part is the same as what we did in the warm-up in our previous example, right? Plug 2 points to the left and 2 points to the right in. So how are you doing on that? So the left and right of 2, right? So how about like -1 and 0 and 3 and 4? How about if you plug in -1, what do you get if you plug -1 in? I'm sorry, why did I pick -1? I meant 1. But actually -1 is good too. I kind of like -1 actually. What's -1? 0, I like that one, actually. -1, 0, all right, cool. All right, well, let's go back to the real question. 1, if you plug 1 in, we get 2 over, I gotta think about this. 2 over -2? Yeah, -1, is that what you're getting? If you plug 0 in, oh, I like 0. 0, because look, it's just that number right there, right? -1/4, if you plug 0 in. And what about 3? What do we get? 4 over 2 is 2. And what about 4? Looks like I get 5 over 4. Yeah? If you plug 4 in, try these things, please. All right, so I'm plotting these now. Here I go. -1, -1. 0, -1/4. Did I get that right? -1/4? Yeah. 3, 2, 4, comma, 5/4 is 1.25, right? So 1.25 right about there. And then I'm going to plot this as carefully as I can. Okay. Still want to say what the domain and range are. So, Alan, what's the domain? What do you want to say? I think you're thinking along the right lines, but. Yeah, we say x is not equal to is what that means. To 2. And what about the range? Megan, I haven't heard from you. What's the range going to be? Yeah. So, I don't have too much more to say about this process. How do you guys feel about it? What's the process? Can you remind me, Jocelyn? For both this and the other kind of graph. All three graphs we've done today. What's the process? Yeah, so it says for Jonathan here. Find the asymptotes. What else do we need to do?
Plot it, probably 2 points, find 2 points and plot.
Yeah, find 2 points.
And then find the 2 asymptotes.
Find both asymptotes.
You find two asymptotes first.
Yeah, do both asymptotes first, and then
Plot points next to that,
how many might be good?
2 on each side.
How about 2 on each side? Yeah, all right. Right. Make sure you label the asymptotes. This is the story. Yeah, Carlos. I'm sorry. I think we said it correctly. We just didn't write it right. There we go. Is it good? Okay. Well, we have a few minutes. I could have started. We do have some application problems we still want to look at. We can do those tomorrow. Your homework tonight is up on the board here, 9.2. There's this new packet, practice A. So flip to the back. You practice